Hello, and welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. Let me tell you a little bit about what this podcast is about. Over the last decade, the paradigm for data access has changed a lot. In today's decentralized world, getting data to remote workers, to distributed applications, multiple cloud regions is a challenge. Data Unchained digs into the challenges as well as the solutions of how to make data an asset as a global resource. Today, we have a guest who has put a lot of thought into the trends of storage systems, data systems, cloud technologies, and really had an interesting write-up recently on the trends going into 2023 that really cover a lot of what Data Unchained is interested in. So I'd like to welcome Chris Evans, Principal Analyst at Architecting IT. Thank you for joining us, Chris.
Hi, Molly. How are you?
I'm doing great. I know you're joining us from London, is that correct? I know you're in the UK.
I live just outside London. I live about 30 miles north.
Okay. And did you make it through the rains and floods successfally?
I did, yes. Earlier in the week we were chatting, weren't we? And I was in York, and they had floods. So the river was flooded, and the apartment we were staying in was flooded too. But thankfully, we made it home without too much trouble.
Excellent. The weather this January has been difficult, it seems like, everywhere. In fact, we had to delay this call for a big snowstorm in Colorado. So thank you for joining us. As we start to get into today's episode, I want to talk a little bit about the history of not just how I've met Chris, but why I thought he'd be a great guest for this show. So I've been in product marketing for ages, and often when we're out doing press conferences, analyst briefings, you're sitting there with a large room of experts in the industry. And Chris has always been one of those people, I haven't told him this, so this is news to him, but he's always been one of those people that I was kind of looking out of the corner of my eye to see the reaction, because while we were always confident in our technology, how you positioned it, did it resonate, did it really make sense to somebody who's looking at a lot of technologies from the outside. So I always had a kind of a corner eye on him to see how the reactions were. And I've really respected your opinion a lot, Chris. So I think it's really fun to have you on this podcast. Before we get going, would you tell us a little bit more? You're involved in a lot of things beyond being an analyst. Can you just talk about various activities that you're involved in?
It's interesting you said about the question side of things and my reaction, because my children disown me whenever we're at any sort of school event, and it'd always be me who put a hand up and ask a question. So they're sort of well used to that issue of me being the person in the room who's more likely to ask a question than anybody else. But in terms of
so
of
do you
what
intimidate
I do,
the teachers?
Sorry, I do like to. Actually, I once took back some work that the teachers had sent home, and I'd red marked it where they'd made some spelling mistakes in the homework and gave it back to them, and they were less than impressed. But I think that's a story for another day. But in general, in terms of what I get involved in, I guess I've been an end user for a long time, and was an end user for about 20 odd years, 25 years maybe. And bit by bit, I started to sort of migrate towards the analyst side. So we've met in things like Tech Field Day with Stephen Foskett, some of the events with companies like Spectralogic and so on. And bit by bit, I've sort of migrated more to being an analyst, but I've done a lot of online writing. I've written for a lot of publications like Tech Target, as well as running a site at architecting.it, which is what you just introduced me as. Funny enough, I've been running a podcast for 5-6 years now called Storage Unpacked, which has looked at data storage products and solutions and so on. And that sort of morphed a little bit into something called the Unpacked Network, where we've got a data channel now and a hybrid channel now. And really that was because I think I was running out of ideas of what to talk about in terms of physical media and storage. So I think you and I have got a bit of an alignment now in terms of the fact that we're talking about the same topics and we have the same challenges to look at in the industry.
Yeah, that makes a lot of sense. You know, to that point of not a lot to talk about on hardware. I think this was interesting. I was talking to one of the big genomics research institutes yesterday, related to my Hammerspace work, not to the podcast. And we were talking about where the trends are going, what they're architecting toward. And he made a really interesting comment that he said, you know, 10 years ago, we were worried about how would we put a certain size genome sequence onto a disk drive and have enough disk drives to put them on. He said, well, disk drives have grown so much since then, but the genome sequences aren't. They're still the same size. And he said, so the challenge isn't about where we're going to put them. That's solved. He said, but now we need to figure out how do we make it have good understanding of what we have and then making it available where we need it most, which often is not local to where the genome sequencer is. And so I thought, that kind of goes along the lines of what you're saying, that there was a lot of evolution in our industry that was really interesting around just capacity and accommodating the massive data growth we had. And it seems things have shifted here in the past, just a couple of years in particular.
You just have to look and see where the growth's going. I mean, I was looking at something this afternoon, and the LTO tape roadmap for the next, however long it comes up to, currently at generation 9, goes up to now generation 14. And at that point, we'll be able to get half a petabyte native on a tape and just under 1.4 petabytes compressed on a tape. Can you imagine thinking back to when we could store 1.4 petabytes on even the storage system? So all of those, I think those challenges around capacity of media, performance and all the rest of it are largely solved. And now we're moving on to how on earth we manage such large volumes of data, putting it where we want to put it, making it accessible, making it secure. All those challenges that are really important, looking at the actual data rather than looking at the physical hardware.
Yeah, absolutely. I used to work for a tape company, Spectralogic, spent a decade there. And at the time, we were trying to determine which organizations need tape and which need for their archive and which really are large enough. And at the time, we said, if you have at least a petabyte of data, then you absolutely need tape because it would be so expensive and almost impossible to store anything else. And now that sounds silly. A petabyte doesn't even seem like that much data. And like you say, at the time, it was a full rack size tape library unit, not a single tape. It's staggering the speed of innovation that has occurred in that space.
Absolutely. I mean, just think about the fact that a cartridge now will cost you less than $200. So you'll be able to put a petabyte worth of capacity on less than $200 worth of tape media. It's incredible. But of course, that drives us to store more data. It makes it easier to store. The more we store, the more difficult it is to manage, and the bigger the challenge there is around making sure we protect it properly and we can access it properly.
Absolutely. So let's talk about software-defined storage. Maybe just as a high-level summary, what does software-defined storage, or SDS, mean to you?
It's evolved, and we'll talk about the evolution over the years. But I think originally it was the idea that we would separate the hardware from the software so that the two could act independently. So rather than building a system where the two were very intrinsically connected and you couldn't actually separate them out. So, for instance, the traditional monolithic type storage appliances of the 1990s. Software-defined storage allowed you to take the two pieces and separate them and deploy the software onto your own hardware. The obvious advantage being that you weren't being forced to pay vendor prices for the technology. So, they weren't gouging you for the fact that a disk drive costs you $1,000 or something like that. But it also gave you more flexibility to choose the size of platform you wanted and so on. And I think it also had a sort of software licensing benefit that you could pay for the software either outright or per terabyte or something like that. So it had lots of flexibility, but really it was the separation of hardware and software initially.
Yeah, I've worked in companies who, through this evolution of the idea of software-defined storage, how they would accomplish this. Because the vision from an end user perspective is fantastic. The idea that choose your preferred software, then negotiate your hardware separately. And that created interesting conflicts on the vendor side of how do we price our product and how do you gain the same value through software only. And it was challenging in the vendor space to look at, well, really it's hard to justify that 70 cents a gig or whatever it is for software only when you looked at your feature set. And so I think it actually really made vendors have to go back and look at what is their true value, what are they providing to their customers that's value add when they aren't the hardware manufacturer. And that's probably what's led to a lot of the technologies that are out today that vendors had to rethink. Just being an interface to the storage isn't enough. They need to do more, add more intelligence, or otherwise, most of them have been either acquired or gone out of business if they haven't been able to evolve that way. But it was definitely a challenge as a vendor working through that space, that even once you had the value in your software, supporting a lot of different platforms is not easy. That's far from trivial to support, different operating systems, different builds of kernels, et cetera. So it's definitely been a journey that I think your predictions and where we are today is going to be really interesting to dig into it a little bit more.
On that note, I think there's a couple of interesting things you pointed out. I think the idea that previous to that, I think if you think about how you buy anything that's physical in the world, the more of that you buy, the more you expect to pay. So if you buy a car or 10 cars, you expect to pay 10 times as much for 10 cars, or maybe you get a discount. But ultimately, when you're buying hardware or physical items, you expect to, the more you pay, the more you get. In the software world, it's a bit different, because obviously you could look at it and say, well, I paid for this software once. Why do I need to keep licensing it every year, or why do I have to buy it again? So the licensing model moves away from the idea of saying, well, you've perpetually paid for it once, so that should last you forever, to one where the vendor really needs to be looking at the features that they add to that software on a continuous basis, so that you always feel like you're getting new value from that software. And I think you're right. That's where it changed the model a little bit. And I do think that's driven a lot more innovation in the market. And, it goes as wide as it goes deep in how that's happened. It's been a very interesting evolution.
So let's talk a little bit about that evolution. I know you wrote an article recently, which we'll drop into the notes of this show if anyone wants to read it. But there was kind of a few phases, 6 distinct phases, in fact, that you called out. First one being about hardware separation. And I think we've talked a fair bit about that. But the idea of commodity servers, I think that's a big deal. And in today's really constrained supply chain, this is an even bigger deal for a lot of customers, that perhaps they prefer HP as their company preferred vendor, but they can't, the lead times are too long, so they would like to switch to whatever, Dell, Supermicro. The idea of commodity hardware and what that brings would be great to have you delve into a little bit, and how you feel like this has been exacerbated with the supply chain challenges.
Yeah, the idea of commodity hardware sounds great on the first outset. I think everybody originally thought, like 15 years ago, that what we would do is we'd just find an old server that was lying around, we'd have some disk drives, we'd stick them in, voila, I've got a storage array now. I don't have to pay my EMC supplier, a fortune for my technology. In reality, that's a rather sort of naive view of looking at it, because ultimately the technology and the way that the software supports it, they have to have at least a certain degree of understanding of each other. So you can't just go and pick anything off the shelf and hope it will work, because ultimately there are corner cases around what will work and what won't work. So in terms of the evolution, that's where we saw some of those points that are in that list of 6 items, where vendors actually started saying, well, let's narrow this down a little bit to something we know we can support and we've tested. So instead of it just being on any old random bit of hardware, you've now got a more controlled environment that really works to the specifications and the performance levels that you're going to expect, rather than it being a bit of guesswork. Now, the sad thing about that is, of course, that you've narrowed down your potential bill of materials to a subset of devices and servers and configurations. And if we hit the supply chain challenge we've had recently, either you as a software-defined user have got to plan to get some of that technology in ahead of time, maybe buy more that you actually need. Maybe you have to go and look at other configurations from other vendors and start testing other things. And if that vendor and that software are connected to each other, that might be a bit of a challenge for you, because that particular software platform might be preferred by a particular vendor. So I think the supply chain issues has allowed people to sort of step back and think, well, maybe we should use cloud a bit more. Maybe we should use something that's a bit more agnostic. Maybe we'll have to buy in a bit more. Maybe we have to be a bit more creative. And I think that has been a problem for people, because they've had to be, think outside the box a bit more.
Sometimes people think of the cloud as something distinctly different that's managed for them and is always available for kind of burst capacity. But I think as these technologies have evolved, it's become clear that really cloud is just another hardware implementation that's managed by someone else. And even with these types of initiatives to go towards software defined, not every cloud instance is necessarily going to be supported by a certain technology or software, just like not every kind of hardware. Do you feel like the evolution of cloud needs to change in some sort of way, or is it more how vendors manage cloud regions to be able to continue on this journey?
I think we've seen some interesting things with the evolution of cloud and software-defined storage and storage in general over, say, the last 15 years. Now, obviously, we started with object storage in Amazon. That was the first deployment, S3. We don't really know how that was put together, but we can imagine it was probably deployed on hard drives, servers, and so on. Over time, we've seen an evolution and an increase in the performance of those platforms. I'll use Amazon as another good example. So they released something called IO2 a couple of years ago, IO2 Express. They very much upped the resilience of that platform and the performance of that platform by adding that new technology in. So in the background, they're always looking at how to add software features into those solutions that they can roll forward for customers and roll them into production. And it could be performance improvements, it could be cost reductions, it could be tiering. And I think that's a really interesting indication of how software-defined continues to work behind the scenes. And it doesn't have to be that we have to see how that's implemented. It can all happen behind the curtain, if you like. And that's probably a good thing, because it means that we don't really have to think too much about the hardware and the underlying hardware that delivers it. We can be more focused on the metrics of what we're getting, the IOPS, the resiliency, the availability, and focus on things that really count to the application rather than focusing on the hardware. I think going forward, we're going to see yet another evolution of this, where a lot of vendors are starting to put their own solutions into the cloud. So these are vendors that have already had on-premises solutions, and now they're going to deliver stuff that runs on virtual instances in the cloud, potentially on local NVMe devices, because that gives higher performance. So the cloud is evolving yet again, but there's always that sort of software-defined element to it behind the scenes.
I think it's interesting as we talk through this evolution. It's been kind of abstracting. The hardware was critical, then it became less critical with cloud, and we keep moving more towards this data-centric focus on how architectures are coming about. One of your trends you also talked about in SDS was containers and Kubernetes, and I think that was yet another step in, okay, how do I make everything more portable and more repeatable regardless of infrastructure? But where do you see Kubernetes and containers in general, not just Kubernetes, playing into this whole evolution of data-centric?
I do love the idea of containers, because it cuts out an entire layer of waste that virtual machines introduced. We were sort of lazy when we introduced virtual machines, because we just took what we were already running, effectively the stack of a bit of hardware, which we virtualized, the same operating system, the same application code, and we lifted it and basically consolidated it onto a single set of servers, which allowed us to just use those servers more efficiently. If you remember back at the time, we had, as an example, Windows as a wonderful operating system. You could get multi-core CPUs where you'd be using one of the cores, and you were wasting a huge amount of resource on those boxes. So server virtualization was great because it consolidated that, but it didn't really make anything more portable than it really was. Yes, you could move stuff around in a VMware environment, but that's more within a cluster rather than, picking up something and instantaneously moving it to another continent. So the container world's changed that significantly, because it makes the application hugely easy to move around. It's a bit of code now. It might need a bit of a download, but as long as you've got that local image, you can instance that application somewhere else really easily. So you could move it from on-prem to the cloud and so on. That's put the challenge back onto the data. And how do we move the data around? And how do we make that data as mobile as the application? So containers has given us a real step forward, but they've also made things a real challenge. And I'm really interested to see technology like the Hammerspace technology, which is looking at how we address that mobility issue. Because if we can fix both of those problems, we can make applications mobile, we can make data mobile, and then we've cracked it. We just become completely independent of any particular platform or any hardware.
It's interesting you drew that tie. That's something that our CEO and kind of chief architect David Flynn talks about a lot. That at Hammerspace, his vision is that we are doing for data what containers did for applications. And you do need both to package it up, know what it is, make it available, move it around, those types of things. And all of these things have to come together eventually for these entire systems to work as really end users envision cloud and decentralized architectures to work. And it's definitely a work in progress on a lot of levels, as we've been talking about over the past. So where do you see things going with SDS? I think one of the trends you called out specifically is you see everything going to SDS. What does that mean to you?
People will say, well, we're already there. Surely every storage appliance over the last 10 years has been software defined. And I think that's true. But at the same time, I think we're moving to a world where features are going to be delivered through the software. So the exposure of those features will be software based. It's not going to be that we'll put something into a server to gain access to a GPU. We can't do that without the software. And as a result, pretty much everything we deliver will be delivered through that storage layer. So I expect we'll see just more and more features going into software that are abstracting and providing a layer that allows us to consume the hardware wherever we are. And I think we hopefully we'll see that degree of abstraction too. The challenge is somehow we have to have a degree of integration here, because if you look, say take hard drives, for instance, or even flash drives as media types, those devices have got a bit of a problem because as they have grown in capacity, they're ever more complex to manage. So the software has to have a much greater understanding of how to manage those components in order to deliver the same level of performance and availability and resiliency and so on. So I think although we'll see a degree of abstraction as far as the user is concerned, the software layer has to become more intelligent to make sure you can use those devices. So software is going to have to get better, but at the same time keep that level of abstraction. So I think there's still a lot of work to do. There's still a long way to go to evolve where we're headed with SDS. An awful lot of work.
So where do you stand on the idea of open source or standards in this whole journey? If you think about integration, is it done in a proprietary way, or is there some other way through APIs or something else that this integration is going to occur?
Yeah, I think we definitely need to have some good standards. So looking back to something you mentioned about David a second ago, if you look back at, say, where Fusion IO technology was when it first came into the market, technology that plugs straight into the PCI bus, but then you had to put drivers onto the operating system to use it. Now, thankfully, somebody spotted that wasn't going to be practical, and we saw NVMe developed as a protocol to directly support those sorts of devices. And thank goodness, we now have NVMe to talk to those devices directly. I think that's a good example where when new technology comes along, we need to really have some sort of standard and API protocol to make them work. And I think whatever we do, we need to keep evolving down that route. If you look at, say, just the raw media, there's a lot of focus on exposing new features, and that is going into the standards. Then there's the question about how you move higher up the stack. Now, how do you, within, say, a file system, make sure that you can move data around in a consistent way? How do you interact with multiple file systems together? We've never really sort of sorted that problem out. You tend to put solutions in that allow you to have data mobility, but they don't necessarily interact. So the answer is, unfortunately, to put in something like an abstraction layer again, and then you've got to think about, well, what is that going to cost me? That might actually be the solution going forward, but it isn't really a standard. So I think anywhere where we can apply a standard, we should really be looking at that and trying to make it consistent and trying to make it not a de facto standard like S3, because at this point, if Amazon changes that protocol, hundreds of customers, hundreds of vendors are going to be affected. So I'd like to see some more vendor agnostic standards for data management, data mobility, and so on being built into the platforms we have.
Yeah, absolutely. A few thoughts as you were talking about that. It's interesting. I don't know as much about David's Fusion IO history. I mean, I do at the macro level, of course, but during those days, I didn't know all the details of what was happening. But at Hammerspace, he did decide to really lean into standards-based architectures. By one of the Linux kernel maintainers for NFS, for example, is our CTO, figuring out how can we contribute into the operating system to standards clients and things like that has been a big push of his. And that's a conversation for a different day related to S3 and interfaces into technology. But I do think the idea of standards-based everywhere possible is super important, and all of us should be thinking about that. And that idea of having customers refactor applications or change interfaces to be able to use new technology is something that's awfully onerous on the customer. And when we think about a lot of the trends I've seen for 23 on customer experience, and that being a huge focus across all kinds of technologies, I think customers will continue to push back a little bit more and more on that because the scale of what they're trying to do and complexity is just too large to be changing their architectures.
Absolutely. And think about where we're going to go. If we talked at the very beginning here about a petabyte on a tape cartridge. Now, moving data around, data obviously has inertia. You can't just shift it around instantly. And as a result, you've got to find other ways to get around that. So either you have to move the metadata, make the data look like it's already been moved, or you're going to have to do an awful lot of heavy lifting if you keep changing that technology that underlies it. So Hammerspace have got a good solution for that, by the way, in the sense that they're abstracting the metadata and putting a layer in between that allows you to swap the physical storage without having to worry about where the data is actually sitting. But that's going to become ever more of a challenge because we're just going to have more and more data to store. So we're going to have to be much more upfront about how we think about that, where we put it, how we classify it, how we make sure that, we tag that data so we know who it belongs to, for what reason, what its requirements are, all that sort of stuff. Those are going to become, super important.
So I think it's worth talking about metadata a little bit. Back in the days of supercomputing, even some of the early IBM technologies and mainframes, there was a lot of thought about metadata. But then over time, really all we got out of file systems or S3 was something that was very basic. When was it created? Maybe who owned it? Some very basic information to catalog and find the file, but very little information about what was inside that file. And we've talked a lot about the idea and the fascination with more metadata is important for everything from machine learning to AI to understanding that petabyte of data. Where do you see that playing into the trends right now? Do you think that's a critical part of this data-centric journey that we're on?
Yeah, so interesting fact. I worked in one environment in 1989, which was like eons ago, on a mainframe environment where we deployed something called system managed storage, or the storage management subsystem. It was part of the IBM mainframe. And within that, every file that you ever created got 4 attributes. It got given something called a storage class, a management class, a data class, and a storage group. The storage group was physically where it was stored, but the other 3 were effectively metadata tags that allowed you to say how the data should be backed up, how it should be protected, who owned it, what it looked like. So 33, 34 years ago, we already had an idea that we should be tagging data at the time of creation. It also allowed us to do processing on the data as it was created, so you could add additional tags in at that particular point. And I think that was really useful because it allowed us then to say, well, if this data is created by this particular user, we put it in this place. We'll do stuff with it as it's created to make sure it sits in the right location. And we threw all of that away, when we moved into the open systems world. And that's coming back again and becoming increasingly more important because in order to manage the data we have, we currently have to do most of that very manually. So, who's the owner? Oh, I don't know. I'll have to go and look, or I'll have to go and find out, talk to people. How critical is this data? Well, data's now changing over its lifetime. It used to be you'd create data, it would age, and as it got older, it would become yet less useful. Well, now, some of that data might come back to being really useful again because we want to do analytics on it. So we might want to store it for some length of time somewhere else, and then it might come back to being critical again, and we have to promote it onto primary storage again because we want to reuse it. So metadata is going to become even more critical than it ever was for automation, for data classification purposes, and all those sort of things that we really need to do to make it useful. So I see metadata coming back in a big way and being super critical to the way we manage data going forward.
Yeah, absolutely. I kind of chuckle, just going back to your mainframe line of thinking, that I post in a LinkedIn group called Storage Experts and read that a fair bit. And there's some 30 or 40,000 people in there. And often when I talk about something metadata, there will be at least one mainframe person who pops in and says, we actually did figure that out quite some time ago. And it always makes me chuckle. And it's true. And so let's talk about data management a little bit more and how that's going to go in the future. I think that, again, thinking about some of the users that I talk to, this concept of enriched metadata is great, but if it's going to require a human being to create it, it probably won't work out. That forcing every end user who maybe is a scientist or an artist or whatever it is to also tag and create manual metadata, enforcing that is going to be very difficult. So a lot of the conversation we've heard is that metadata creation has to be more computer generated, has to be accessible to the workflow tools that users are accustomed to. And I feel like that's going to be a big key, is those workflow integrations that are at the machine and not the human level. Would you agree with that?
Absolutely. So I'll give you a good example. My eldest son, he's doing his PhD at the moment in biochemistry. And he said to me the other day, he's got a real problem trying to run some of the AI models they run against some data. File system was full and he couldn't work out how to resolve it. And we sat down for about half an hour and he took me through the structure, and the structure of their file system was all over the place. It was managed via his tutor, who has the high level authority, but he has a shared folder out of that, but it's linked to his personal account. And then when we tried to sort of dig out where this was all sitting, it was all spread across about 3 or 4 different servers, which were really bizarrely interlinked. And I got to the conclusion where I said, I just can't work out what's going on. It's very difficult to identify exactly who owns what and why these permissions have been linked and how it's been done. The only thing you can do is go back and ask him exactly how to interpret this. So he'd wasted a few hours, and already we wasted a little bit more time, but we got nowhere. And I think there's the first step, the fact that the actual manual process of making sure you keep things tidy isn't part of somebody's primary responsibility or job. So they're not going to waste hours making sure that their file structure looks pristine or they've added the right metadata, because they just want to do their job. They want to do whatever the job is that they're doing. So the systems need to come in and help that and fix that problem for you, and either stop you doing stuff you shouldn't do or add that extra data to help you do it. And one other interesting angle is I actually do some work with another company as an advisor, a company called Petagene, and they have some technology which allows them to make data a bit more mobile, but also secure it at a very granular level. And technologies like that, I think, will really help in this, because then you can expose data to people in a sort of secure manner and know that if you take that permission away, you can take that remote access away too. So there's lots of other little things coming in here to not only allow you to do, say, metadata tagging, but also manage the security side of it too, all of which have to work really well and really integrated in an automated way, simply because people just won't look after keep things tidy themselves. It's just not in their nature.
Yeah, that idea of security and data management being so closely coupled, I hear almost daily in the customer interactions I have with. In that situation, for example, your son really is not supposed to be an IT expert if he's trying to go into biochemistry. It's nice that he has a dad who understands this stuff, and he probably intellectually understands it too, but that shouldn't be his expertise. And the nature will be, okay, store it locally. Now all of a sudden it becomes my copy of data. The organization can't manage and secure it. They don't have access necessarily to my data when it really should be our data. It creates all kinds of problems when the IT systems are too complicated. And of course, security is such a big concern right now of, not just systems being hacked, but, the corporation knowing that their data asset is accessible to the corporation, not just to an individual, is a part of this data journey. That data is the most valuable asset to a lot of organizations now, or one of the most, the people who create it and then the data itself. So how do you feel in the future data management will help address this, or what do vendors organizations, standards groups need to do on the data management side to help with this?
I think there's still a long way to go. I mean, just talking about the security model, you just mentioned that side of it. And one of the big things we see people talk about now is things like ransomware and data being encrypted. And the route everybody's looking at is things like zero trust and saying, well, you only get access if you should do. In my son's example, who knows what access everybody should have had? Somebody might say, yeah, give them permissions, for a couple of hours and then forget, and then it never gets taken away. And I think the tools aren't necessarily there to allow us to do that as easily as we'd like. So I think we need to do a number of things. We need to sit down and really think what we're trying to achieve here when we're protecting the data, and we need to think about how that is going to be achieved. So I think it's wrong to have piecemeal tools that are going to do things, little pieces of this. I think it really needs to be brought together in one place. Now, typically the file system, if it's all file data, seems to be the one place that is available to do. And I think what we need is to build in these features into the file system. So we should have greater security. We should have greater ability to give permissions. Those permissions should be, if we need to, time dependent, whatever it happens to be, but we need that level, I think, within the file system. We need a lot more auditing and tracing so we can see who's given those permissions and when and why. And a lot of that isn't necessarily that easy to see. And then within that, we need the APIs within the file system to allow us to move that data around as we need to. So for instance, if we decide we want something on a different tier of storage, we should be able to do that at the file system layer. And that's where that should occur and can be done automatically against policies and various other things. And it seems that more and more that I look at this, and I know we're on your podcast talking about Hammerspace here, which obviously is part of it. But I think genuinely more and more as you look at this, the sort of the locus of control, if you like, the central point for this has to be the file system. And that's where all the rules and the responsibilities, the APIs, the interfaces, they all have to exist within that. So I think that's where the industry needs to head. They really need to look at it and think, how do we bring all these things together in that one place that really make it work efficiently?
So the last question I'd like to touch on is the idea of data mobility. And you've talked a little bit about thinking about how the file system can control a lot of these aspects, or can be a point to manage a lot of the concepts around security. When you think about data mobility, I think largely in the past, we thought about data mobility being for tiering reasons. Get it to a less expensive tier, a lower performance tier until you need it. So it's kind of tiering up and down a storage stack. But now in this decentralized world, data mobility to get to a different cloud region, a different cloud service, because you needed to engage remote workforce in another country because there wasn't sufficient workforce in your own country, whatever it may be, moving data has become about primary data and not just about archive data. Where do you see technologies today? Is it companies like Petagene, or will those eventually be integrated into the file system too? How do you see that data mobility working in the future?
Yeah, I mean, funny enough, they do it at a file system level. They do actually sit in the not the data path, but they sit and intercept I/O requests. So they, if you're opening a file or closing a file, they're getting in at that level. So effectively, they are in at the file system, if you like, the I/O operation at a file level. I think we ended up, with three different ways of doing this. We can actually physically move data around by copying it, which is a nightmare. Because as soon as you create a copy, you've now got a discrepancy between who's got the current copy and who's got the inaccurate copy. That just doesn't work. The second solution is we end up with file systems where we add pointers to things, where we start putting in references back, and we use that sort of methodology. That sort of works, but it doesn't really work, because then you can't really sort of see the whole of that, and you potentially have got two layers of metadata. You've got the metadata where the original file was, and then you've got metadata to where you've moved it, and you've got to keep some sort of relationship between the two and keep a database to keep track of that. So that introduces a lot of challenge too. I think what you have to do is accept that there are two components here. There's the physical data and there's the metadata. So you can have a view of the data and say, well, here's my entire data estate. Here's what I own. Here's what I've sort of collected together. And then you've got a map that says, well, here's where it's currently physically sitting. If you're clever enough, you could go down to a very granular level and have it dispersed across different locations. There's a massive amount of additional checking and locking and to make sure you can make that work properly, but you could do it. And I think when you look at, say, a data set where somebody might want to use 10% of that, you're not going to shift the whole thing over just so they can access that 10%. You're going to move the 10% you want. You might not know that in advance, but you might know that in advance because it might be a structured platform sitting on an unstructured data source, like a database or something like that. So I think there are techniques that we can use, and I think AI will come in there. I think the whole AI ops thing to analyze data patterns so we can see how data profiles of how people are accessing that data work. That can allow us to move the physical content a bit closer to where it needs to be without actually having to physically move the whole file. So we need to abstract. We need to separate the data from the metadata. We need to add additional metadata in that helps us understand what the I/O profiles for that usage is going to be. And then we have to use those sort of tools in the background to help us physically put the data where it needs to be at any particular time. And a good example for that would be look at the egress charges of taking data out of something like S3. If you could just map the metadata that you had so that you knew what metadata was or what data you had in another location based on the metadata, when you wanted to access that data, you could only move out the pieces you need. You wouldn't have to move out the whole lot in order to access it somewhere else. So there's actual cost savings involved here and various other pieces that could be really helpful. So I think we really need to focus on how we make that work. And if we could get that to work, we'd be in a state of nirvana, I think, with the way that we handle data mobility.
I think that makes a lot of sense. So Chris, as we tie up, if other vendors and users would like to get in contact with you to talk about some of the topics we have today that are more specific to their environments, what's the best way for them to reach you?
Yeah, sure. You can find everything I write at Architecting IT, which is the blog, the website, and there's some contact details on there. I still use Twitter, so you can get me at Chris M. Evans, or you can find me on LinkedIn as Chris M. Evans, just to differentiate me from the famous actors, that, and the UK DJs, because there's a lot of Chris Evanses around out there. But if people want to contact me, just get in touch, and I'd be very happy to respond.
And then, as we look at the next year, where do you think people can continue to learn? We talked a lot about trends and things that should be happening in the standards world and from vendors. Where is the places you would point customers or end users, architects to keep kind of their finger on the pulse of these topics? Do you have a favorite place you like to read?
Apart from my stuff, that's a good question. I guess I tell you what I would point people to. I'd suggest they go and have a look at the Tech Field Day stuff. Mm-hmm. A lot of the stuff I've done over the last 10 years has come from the start of the Tech Field Day event and what Stephen Foskett's done. There's a lot more content over there now, but there's an awful lot of historical content on there. All the videos going back, I think, to the first edition in 2009. I think we did the first one. They're pretty much all there on YouTube. So there's a huge amount of stuff you can go back and find there. I definitely recommend doing that.
Well, thank you for joining. Really interesting conversation. I always enjoy the chance to get to speak to you about these kinds of topics. It's fun and always a challenge. If you guys read Chris on Twitter, that's where you see the more edgy side of his commentary, and then his more polished, politically correct comes out on Architecting IT, and both have a lot of value for sure. Chris, thank you so much. I'm glad you made it back through the wet environment out there in the UK, and have a great year.
Thank you, Molly. It's been great. I really enjoyed it. Thank you.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.